Welcome to NASA Edge.
An inside and outside look at all things NASA.
I tell you what, Blair, I'm so excited. This is going to be the last tower rollback of the Delta II.
Chris, it might get emotional. After talking to several folks around here, lots of people have worked on the Delta II over the years. A lot of people are here for that in addition to ICESAT 2. Very special moment.
Tell you what, over the course of the next hour, we're going to be talking to a lot of subject matter experts about the ICESAT 2 mission and the Delta II rocket. And we have a very special guest. For the first time on NASA Edge, we had the Associate Administrator for the Science Mission Directorate, Thomas Zurbuchen. So I'm looking forward to talking with him.
Yeah, pressure's on.
It is on. And joining us now is Thomas Zurbuchen, who's the Associate Administrator for NASA's Science Mission Directorate. Thomas, great to have you on the show finally.
I'm so glad to be here. I watch you all the time right outside my office.
You don't get sick of us, do you?
Oh, no. It's interesting. Sometimes I get stuck there with my coffee and listen to you.
I tell you what, NASA has a rich history in science. What's science role in NASA?
Look, I mean, from the beginning, remember, it's our anniversary year. From the beginning, science was an important part of NASA. Of course, we see human exploration and discovery as one and the same activity, two sides of the same medal, right? And so for us, we explore some places where we go with humans, and when we're there, we do science that we've never done before, and we're doing that right now, and we're going to do it as we go forward into the next 60 years to the moon, to Mars and beyond.
And speaking about science, let's focus on Earth science, because with ICESAT 2, the Earth is a very complex, dynamic system that we really don't understand well yet. How does ICESAT 2 fit within the Earth science program portfolio?
So we have right now 105 missions in NASA science that we're working on. Earth science is 39 of those.
Wow.
19 of them are right now flying, and we're working on 20. And of course, those numbers will switch tomorrow, right? As we put one up there. And so the NASA program focused on Earth science is very robust. And just like you said, the reason we have so many missions is because we need them to really understand that complex systems. What we're going to look at with ICESAT 2 affects our lives here in California, our lives in Michigan, our lives in Washington, D.C., in a direct fashion, and everywhere else on Earth.
Now we had a big year in science, but we have a lot coming up in the next year or two. What are some missions we can look forward to?
Well, I'm really looking forward to just some milestones like InSight arriving at Mars. Of course, kind of always an Earth-wrecking thing. Remember, kind of humanity's batting 40% on landing on Mars, right? So less than half the vehicles actually work. The good news is that the team that has been successful in all of them is in our corner. So it's always great to have the best team in the world right there, right? So I really look forward to that. We have other milestones like arriving at Bennu with OSIRIS-REx. And at the end of the year, New Horizons is flying by an object we've never seen. So we're full of discovery. Many things are happening. New launches, OCO3, looking at the carbon dioxide and other compounds in the atmosphere. Many instruments coming up, including also ICON, looking at the upper edge of the atmosphere that's influenced by the atmosphere and by space weather.
Well, Thomas, I know you have a lot going on your plate. You're going to be on console for the launch tomorrow?
Yes, it's going to be the first time on console. Of course, I'm always excited to see the people work, because what makes mission successful is the team, not one individual.
Well, good luck with the launch tomorrow morning.
Thank you so much.
So Tom, NASA's been studying the cryosphere for a long time, and ICESAT is really sort of the main mission in studying the cryosphere. Tell me a little bit about ICESAT.
The first ICESAT launched in 2003, and it was on orbit until 2009. The main purpose of ICESAT was to measure changes in the ice sheets. Are they getting larger? Are they getting smaller? How are they changing? And the way it did that was with a laser altimeter. It sent out small pulses of laser light that bounced off the surface of the Earth and came back up to the spacecraft. By timing how long that light takes to do that round trip from the spacecraft to Earth and back again, we can figure out how far away or how near the surface of the Earth is. And by measuring the height of the ice sheet at the same place through time, you can measure whether it's growing and getting closer to the spacecraft, or is it getting smaller. And what we found with the first ICESat was that Greenland is changing quite a lot, particularly in the edges of the glacier, that it's losing a lot of mass there, where the ice sheet's getting smaller, and that water's being lost to the ocean, and causing sea level rise.
Now, what happened between ICESat and ICESat-2? I understand there was a bridge. You had to keep on taking measurements between the ICESat and ICESat-2?
That's right. After the first ICESat mission ended in 2009, we knew we had to keep monitoring how the cryosphere was changing for ice sheets and for sea ice. And ICESat-2 is on the horizon, but was quite a ways away at that point. So what NASA decided to do was to use an aircraft mission, which they called Operation Icebridge, to continue to monitor those places that were changing rapidly. They use the P-3 aircraft as well as the DC-8. They do about a month-long campaign or 2-month-long campaign each spring in the Arctic, and a similar length campaign to monitor places in Antarctica. With an airplane, you can fly many instruments. They use a laser altimeter, similar to what we use in space, as well as radars and cameras to measure those places in the cryosphere that are changing rapidly.
Any ground instruments that you use to measure the elevations?
You know, places like Greenland and Antarctica are huge. You can't really credibly cover much of that on the ground. They're simply too big. But a natural question is, how do you know that the measurements from the aircraft or from the spacecraft are correct? So what we've done is go to Antarctica, near the South Pole, where all of the ground tracks from ICESat-2 converge. ICESat-2 will be on orbit. It goes up to 88 degrees north and 88 degrees south around the Earth. So we went to 88 degrees south, and we took some high-precision GPS instrumentation to make a detailed survey of about 300 kilometers of the ice sheet. Now, that survey is going to be one of our main reference data sets. So when ICESat-2 passes overhead and gives us some data from that area, we can compare the two and see how we're doing. Similarly, Icebridge, the aircraft campaign, flies over that same stretch of Antarctica, so we can compare the ground-based to the airborne to the spacecraft.
Now, I understand ICESat-2 is a much better satellite and a much better instrument on board. Tell me the difference between ICESat-2 and then the original ICESat mission.
You know, with the original ICESat, we had never done that before, have a laser in space to measure changes in ice sheets, and we learned a ton. We learned that the main action is around the edges of the ice sheets, but as importantly, we also learned that we could monitor sea ice with that. And by measuring the height of sea ice and comparing it with the height of the ocean that you can see in these cracks in the sea ice, you can figure out how thick that sea ice is, how much is sticking up out of the ocean. And we didn't even know we could do that with the first ICESat before it launched. So for ICESat-2, we used those lessons, and ICESat-2 will do a much better job of measuring changing glaciers around the edges where it's rough and it's steep, as well as measuring sea ice freeboard as that way to get at the thickness of the sea ice.
In addition to the cryosphere, I understand ICESat-2 is going to be taking elevations of a number of areas around the globe. What are some other things ICESat-2 can do?
So from the vantage point of space, you really see the whole planet. Although ICESat-2 is really designed to measure changes in the cryosphere, the ice sheets and sea ice. From the vantage point of space, you see forests. We'll measure the height of oceans, height of deserts, all over the whole planet. We have data products that cover each of those different types of surfaces. We have vegetation data products, ocean height, ice sheet height, sea ice, etc. The cryosphere is our primary objective, so the other targets are secondary, but we think they're going to be really useful for those communities.
Will you be able to predict down the road, I mean, just how much the poles and how much ice is melting and how much of the ocean levels are increasing over time?
Absolutely. So with ICESat-1 and now with ICESat-2, we'll be able to measure those changes in ice sheets and measure how much mass is being gained or lost in different places and how that's affecting sea level. But you bring up a good point that our data will allow ice sheet modelers to make better predictions of the future. And the way they do that is by comparing their model prediction for right now with our data. So if a model is predicting that a glacier is changing this fast or that fast, they can compare their prediction with our data to see how the model is doing. And by calibrating their models with data, it gives us more confidence in their predictions going forward when they're predicting out 100 years or 200 years. If you're getting the modern changes right, it gives you confidence looking ahead.
And we're back now with Kelly Brunt, a science team member of ICESat-2. How you doing, Kelly?
I'm doing really well. I'm excited.
You know, Tom did a great job talking about the overview of the science mission behind ICESat-2. What is your role as a science team member?
I'm part of the Project Science Office, and ultimately my main responsibility is associated with post-launch validation.
Okay.
So I was on that mission that Tom was on in the Antarctic. We go out and we collect ground-based data, which includes not only location in XY space, but also precise ground-based measurements of the height, and we compare that directly against the satellite data that we'll be receiving later.
Now, since you're an expert in working in the cold environments, Antarctica, Greenland, how are the ice sheets doing right now?
So the edges of our ice sheets, the parts of the ice sheets that are in contact with both the atmosphere, our warming oceans, we're losing ice in those areas. And we learn that with ICESAT, and we continue to measure those changes with IceBridge.
Right.
ICESAT 2 will be the next step in adding to the time series of how these ice sheets are changing.
And I'm assuming then that change between, let's say, the Antarctica and then Greenland, it's different in terms of the percent change.
Absolutely.
Okay.
On top of that, the dynamic parts of the change are very different. In Antarctica, our loss is through mostly calving events, big iceberg calving, and melt from underneath the ice sheet where the ice sheet is in touch with the water. In Greenland, it has to do more with surface melt and to a lesser degree calving, but that basal stuff goes away. In Greenland, the real story there is the surface melt of our ice sheets.
Now, I think a lot of people want to know out there, what is it like working in Antarctica?
It's fantastic. I
Is it?
think it's not quite like going to space, but it is a scene that not a lot of people get to see. So it's very special. It's cold, but it's exciting, and the work there is rewarding in its own way. It's
Recommended
fantastic.
vacation spot?
Absolutely.
Oh.
Yeah, 100%. Yeah, base center of the ice sheet. Get up high where you can see everything.
Well, Kelly, thank you so much for joining us today
Thank
on the
you.
show, and good luck with the launch tomorrow. We're looking forward to that last Delta II rocket.
Thank you so much. This is great.
Danya, a lot has been made about the improvements between the ICESAT mission and the ICESat-2 mission. You've been working primarily with the instrument, the ATLAS instrument. What is the ATLAS instrument, and what are the improvements that that instrument brings to this mission?
ATLAS is a laser altimeter. It's an instrument that is about the size of a smart car, weighs about 1/2 ton, and it has 2 lasers. I like to call it a sophisticated stopwatch. It can measure the changes in ice elevation down to the width of a number 2 pencil. And the lasers actually fire from, let's say, the distance from Washington, D.C. to Cleveland in 3.3 milliseconds.
Now, it's funny because that seems like it would have to be a powerful laser to reach that distance. But what I've heard is that it's a low-power laser. How is this possible?
You can describe it as a high-power laser and a low-power laser. It's relatively a high-power laser, but we spread the beam out so that when it reaches the ground, the energy density is much lower.
So the ATLAS laser is very sophisticated. How does it actually get better or more data for the ICESat-2 mission?
Sure. One of the differences between ICESat and ICESat-2 is that ICESat-2 splits the laser into 6 beams. That allows us to cover a larger area, and it also allows us to have more discrete measurements along the ground, which gives us higher granularity and data in those measurements.
So obviously ICESat-2 not only is using this more sophisticated instrument, but it's getting a significant higher amount of data.
Yes.
So how do you process the data on the spacecraft and get it to the ground stations?
Oh, that's pretty exciting. I love talking about this because it's pretty interesting. So we have a very sophisticated, I like to call it, map on board. It's actually the digital elevation model. And our receiver algorithm team, as part of our testing, they actually identify the area of interest based on where we are over Earth. And they're able to modulate the amount of data that actually gets time tagged and dumped to the ground based on where we are and how much data is needed in order to be able to make an accurate measurement.
You're really collecting data on the differences you see from this map.
Yes. So we're collecting data not only on the differences as the observatory takes measurements, but we're also taking, modulating the amount of data based on the surface type. So if you are taking measurement over a flat surface, a relatively flat surface, then you would need less data than if you were taking a measurement over a surface that had a lot more differences in the terrain.
There's so much to be impressed about with regard to ATLAS and ICESat-2, but what are you most proud of?
When I think about it, there are three things that I'm proud about with respect to ATLAS. It's one of the largest and most sophisticated instruments that's been built here in-house at Goddard. took a large team in order to build that instrument. We had about 350 people, and I can say that it's one of the best teams that I've ever worked with.
Mick, the last time you and I were here, it was for the JPSS-1. We kept saying it was the second to the last Delta II tower rollback. And now we're here, and it is the final Delta II tower rollback. How you feeling now?
I tell you, it's a little emotional to be out here getting ready for this final rollback. JPSS-1, the penultimate, was a great rocket and time to be here, but it's all about ICESAT 2 as we get ready for mobile service tower rollback. The teams have done all their work, they've prepped. They're doing their final walk downs. They've removed the ordnance pins. They're getting the vehicle ready so that they can remove the tower and prep for launch early this morning.
Mick, let's talk about the configuration of this Delta II rocket for the ICESAT 2 mission.
Yeah, this configuration's a little different than what we saw on JPSS-1, which was a 7920. Tonight, for ICESAT 2, we actually have a 7420. It's a 7000 series Delta II, 4 meaning 4 graphite epoxy solid rocket motors, which help provide thrust with the RS-27 first stage engine to get out of Earth's atmosphere. The 2 references the second stage AJ-10 engine, which provides that boost for ICESAT 2 once it's into space. The 0, of course, means no third stage on the ICESAT 2 mission. We're only requiring a second stage 2 burn mission to get into space and do the orbit it needs.
Now, Mick, you and I both attended the flight readiness review where our launch director, Tim Dunn, started talking to people about what's your Delta II number, and what he was insinuating is, what's the first Delta II that you worked on? And so, Mick, what was the first Delta II that you worked on?
So my first one was Delta 294, ICESAT chipset, the predecessor to the ICESAT 2 mission. So I feel very well tonight being bookending both the science missions with the original ICESAT and then ICESAT 2 launching tomorrow morning. And you know, when we refer to the number of deltas, the Delta family has been numbered sequentially since its inception, and so that's what we refer to as a number in a row. ICESAT 2 is going to be Delta 381, and as Tim pointed out in our readiness reviews, the Delta tent is a big tent, right? And we welcome everybody into that. So we have folks here that are part of the 381 family. But Tiffany, importantly, what was your number?
My Delta II number was 261, and that was deep space spacecraft, and that was actually the beginning of LSP's 20th anniversary. But for our audience to participate, what is their Delta II number? How can they figure that out?
You can go on the internet, look up the Delta launches, and what I would encourage you to do is figure out what the first Delta II that you watched was, and that's your Delta II number.
Now, Mick, you got to interview a ULA subject matter expert with part of the Delta program. Let's check that out.
I'm so excited to be here at the United Launch Alliance's rocket factory and the chance to walk down this facility and see where the historic Delta II has been produced. Dana, that has to be exciting for you also, this final Delta II coming up. Can you tell me a little bit about yourself and how you got started in this business?
I got started at the very beginning, a little prior to Delta II in Pueblo, Colorado. Started in Pueblo, Colorado. We started with the last of the 6 Delta I's. It was coming back from where President Reagan had decided that we needed to bring back Atlas and Delta again from the shuttle explosion. And we did the last 6 Delta I's. As we were doing that, we were working on this new Delta II. And it took a while for the first one. I think it took us about 10 months in the factory to build the first Delta II. So it was a kind of a conglomeration of Delta I and Delta II. In Pueblo, we built about 120 Delta IIs in Pueblo. And we transitioned here in 2004. And we built another 30 or so Delta IIs here.
Yeah, you talked a little about Pueblo, Colorado, right? The early Deltas or Thor missions, which Delta had evolved from, were built in the Huntington Beach, California area, and then in Pueblo, Colorado. And then you talk a little bit about transition here to Decatur, Alabama, where the Delta IIs were made, right? Final Delta II, ICESAT 2, that's out there on the pad. That's got to be really exciting, historic mission for us at NASA and for United Launch Alliance. Share a little bit about what you've done to prepare that vehicle for its final launch.
Well, first off, I'm very, very fortunate to have been able to work on every single Delta II. And to prepare that launch, we took extra care on the last 4. We weren't in full bore production, so we took extra time, and the last 4 were very special to us, and we spent adequate time, and they were special. We knew they were the last ones.
You know, McDonnell Douglas, who started the Thor Delta IIs, Boeing, and then now United Launch Alliance, unique thing they did, right? You work in the production area, but whenever there were problems at the pad, you guys got to travel down to the launch pads and do repairs on the vehicle as production engineers, right? So tell me a little bit how that was, going to the East Coast at Complex 17 and the West Coast at Space Launch Complex 2.
Oh, it was a great experience, and they did that because we were experienced with the build problems, and we put in all the parts. So the thinking was, if it's more than a simple change, we'll just get the guys out that normally do it and keep that experience base. So it was spectacular when you go out to the launch sites and get to work on a launch site. It was really special.
Awesome.
And the whole group, we were always kind of a small group, so we really weren't like a job or anything. We were like a family.
Yeah, you know, when we were walking around, what I noticed was how involved people were with Delta II production, how excited they were with the Delta II vehicle itself. There's a lot of memories with it, and you guys took a lot of pride in the work you did. You mentioned you took a little bit longer time on these last 4. You know, NASA bought these last 4 in 2012 for our 4 missions, OCO2, the Orbiting Carbon Observatory, SMAP, the Soil Moisture Mission, and JPSS-1, our Joint Polar Satellite. And now, of course, our last one, ICESAT-2, which is our ice monitor. We're excited to have Delta II launching these, and you know, it's been a workhorse for NASA over the years. And reliability, let's talk a little bit about reliability. Delta II is one of the more reliable rockets that's out there, right? You guys hold the world record for most successful launches in a row.
That's true, and we're very proud of that. And one of the things that helped us get there was science missions. To me personally, science missions were very personal, because I knew many, many times that it would take 30, 40 years for the technology to mature before you could get a good satellite up to do what you wanted to prove. We knew that when we'd meet the scientists and stuff, they'd come and look at the launch vehicle. They had all their budget, their whole career was tied up in this one launch. So we would try to make them as perfect as possible, and we would be kind of OCD going over them and checking them. I'd drive people nuts, but our team, we'd put them together, and we'd just try to make the best product we could. And in the science arena, she's done probably 50-some science missions. 8 or 9 of those have gone to Mars. I mean, when you get years ago, when you're working on a Mars mission, you're like, wow, this is special. It's very special.
You know, when ICESAT-2 launches, that will be the 100th successful launch of a Delta II. That's got to be exciting for the folks at United Launch Alliance and yourself as part of the production team.
Yes, it is. It's quite an accomplishment. We're happy and we're thrilled, and we're all looking forward to that 100th mission. Go Delta II.
5, 4, 3, 2, 1. Liftoff of the final Delta II, launching nearly 3 decades of science research and exploration missions, lifting ICESAT-2 on a quest to explore the polar ice sheets of our constantly changing home planet.
Well, we may have missed the tower rollback for Delta II, but there you have it, the 100th consecutive successful launch of this historic Delta II rocket. You're watching NASA Edge, an inside and outside look at all things NASA.